In this video, we're going to take a look at some of the details of the thread class. So the thread class um, has multiple methods that we can use. We'll talk about some of them as we go. So we have thread constructor, which will create an empty thread. The one we've used so far is thread where we pass it one of our tasks. And remember, it can be any task that implements runnable. We can start a thread with that task in it. Thread.start, we've seen that already. That starts the thread and causes the run method to be invoked by the Java virtual machine. Some other methods that are in here, there's an isAlive method that tests to see if the thread is currently running. So once we've created a thread, we could call its .isAlive method to see if it's still running. There's a set priority method we're going to talk about in a little bit. There's a join method that will allow us to join a thread to another thread. There's a sleep method that we can specify how many milliseconds and we want a thread to sleep. So if we want to allow some other threads to run, we can make one thread sleep. There's a yield method that causes the thread to pause and temporarily allows other threads to execute. And there's an interrupt if we want to interrupt a thread and stop it from running. So let's look at the yield method. So we can use the yield method to temporarily release time so that other threads can run. So for example, suppose we modify the code in the task thread demo that we previously saw. This is the one, well, let me pull over an example that I've created. The print character function. I added a thread.yield to that so that the printing characters, if you remember, the characters were almost complete before the numbers even had a chance to run because these small demos execute so quickly. It's kind of hard to see some of these things. But I did add a thread yield into that, and so that when it runs, we can see that after the initial running of print character A and print character B, once the number thread actually gets started, the print character fields are yielding to it quite a bit more often. And we're seeing a lot more numbers mixed in here while the A thread and the B thread are being completed. We see the A thread and the B thread yielding a lot more often. So we get the numbers in here completed early. I printed this up to 1,000. Even so, the A and the B threads still tend to get done pretty quickly and just leave a few hundred numbers here at the end that run by themselves by the time it's done. So that's something to be cautious of when we're trying to do these little demos to show multi-threading and some of the commands that we can run. It's hard to see some of them actually run with these small demo programs because things happen so much and nothing is guaranteed on a lot of these things. We're going to see that coming up with priority. A lot of it's dependent on the operating system and the Java virtual machine. And just because we add something in a short program like this doesn't mean we can actually always see the things happening. Larger programs with more complex things that take more time, obviously we may see more effects of these, but we're going to talk about them anyway. And right now, all we can use is some simple examples. So we have the sleep method. The sleep method puts a thread to sleep for a specified time in milliseconds. For this example, we can modify a run method and add thread.sleep right here, and this is telling it to sleep for 1 millisecond. Okay, so this is in the number counter when it's counting up to 50. Once it gets to 50, every time it does another number, it's going to tell the thread to sleep for a millisecond. Now, a millisecond seems really short, but it's not all that short. So I have a demo of this. Let me pull it over here, and we can see a little bit of the effect in this. So this is the sleep demo method. And we can see here in the print number class, I added thread.sleep. Okay, and we're telling it to sleep for 1 millisecond. Now, one thing we need to know is that thread.sleep can cause something called an interrupted exception error. And in order to be able to do this, I had to enclose this in a try catch because it's a checked exception. And remember, for checked exceptions, we always have to use a try catch. So I put a little try catch in here so that we could see it run. But really, the only really effective code that I change is adding the thread.sleep, but only when I gets over 20. So once that counting gets up to 20, so here our number thread started counting, and it managed to count from 1 to 15 before the A thread took back over, and then the B thread for a little bit, then some more A's, and then we went to 16, 17. The counting thread got up to 20 there. And remember, once we hit 20, it's going to sleep after every number. So 20, I told it to sleep for a millisecond, and it got all of this work done. All these A's and B threads managed to run in that millisecond before 21 actually, and only one number here. So it did 21, and then it went back to sleep for a millisecond, and these other threads took over, and we got a whole bunch of numbers out. Matter of fact, A thread and B thread completed, and then at the very end, we ended up getting 22 through 100 here. And I believe I had A and B printing each 1,000 times. So you can see that sleeping for a millisecond really caused a lot of work to get done when that ran. All right, that's the sleep method. The join method. You can use a join method to wait for one thread, to make one thread wait for another thread. So in this example, and I don't have a runnable version of this, so let's just look at the code. We're creating a fourth thread, but it's inside the run method of one of our other tasks. This is our number printing task right here. So we created another thread in there, a new thread that prints character C 40 times. And we started that thread. So this thread started running the minute this other thread started running. So what happens is once our numbers, when they're printing out, gets to 50, we tell it to join, we tell it to join thread 4, and that's this one up here, okay? Which means that thread 4, until it completes, the rest of these numbers won't print out. So the numbers after 50 won't finish until print A gets done. All right, so that's the join method. Create a thread, make a thread, wait till another thread gets done. Basically, when you join it, it makes that thread wait till the other thread is complete. The isAlive method is used to find out of the state of a thread. It returns true if a thread is in the ready, blocked, or running state. It returns false if the thread is new or has not started, or if it's finished. The interrupt method interrupts a thread in the following way. So if a thread is in the ready or running state, its interrupted flag is set. If a thread is currently blocked, it is awakened and enters the ready state, and an interrupted exception is thrown. So the isInterrupt method tests whether the thread gets interrupted. Okay. Now, there's some old methods that you may see in legacy code, the deprecated stop, suspend, and resume methods. The thread class contains those methods, but after Java 2, so you probably, at this stage, you're going to have to be working on some pretty old code to see it, but they're in there. They're deprecated. That means they're outdated. So support is still there for them. Meaning, if they just got rid of it and took it out of Java, that would break a whole bunch of people's programs, right? So they call it deprecated, which means don't use this anymore. And you should think about updating your old code. Eventually, deprecated methods, deprecated anything, will go away and won't exist anymore. The reason they deprecated them is because they're inherently unsafe. They don't run reliably. So the suspend, resume, and stop methods should not be used. The best way to stop a thread is to assign a null thread to a variable. So if you have a thread and you want it to stop, you actually assign null to that thread's variable, and that's a better way than using the stop method. So know about those. You probably won't see them, but know about them. Okay. And then here's another one. Each thread can have a priority. And this is one of those ones I actually did this and did a demo of it, and I set the priorities, and you cannot see a difference for these small programs. So each thread is a default priority of thread.norm priority. Okay, and technically the numbers from 1 to 10, I believe. Norm is like 5, max priority is a 10, I think, and min priority is a 1. So you can call set priority on a thread, so the name of your thread, so we can say thread 3.set priority. And theoretically, if we did that, that thread should finish first because it has more priority. In reality, it will run more often. It'll have the highest priority, but a lot of it is operating system dependent. So there's never any guarantees. It should run more often and should take a higher priority. In these tiny programs like this, though, they complete so fast, it never really demonstrating that in one of these small programs, you just can't see it. It just doesn't run. They run way too fast. All right, so that's the thread class and its methods. We'll get a chance to explore some of those things a little bit more in upcoming videos.